What's up guys, welcome back to Tank Control Games. This is episode 3 of my Resident Evil style camera system tutorial in Unreal Engine 5. If you didn't catch episode 1 or 2, make sure you go back and watch them before you proceed here, otherwise none of this will make sense. At the end of the last episode we had all 3 of our camera types working, our fixed camera, our tracking camera, and our on-rail camera, but there was some issues with the input when the cameras would change. Sometimes the player would want to turn 180 or turn right and just not go the direction that you actually want them to go in. So that's what we're going to fix in this episode. This is really going to help our modern fixed camera controls feel really fun and intuitive to play. So let's open up our project and begin. Okay, so once your project loads, let's click run and test something out. I'm going to walk kind of straight at that green arrow, and I would expect to keep going forward, that same direction, but you'll see something interesting when we cross over. So I'm going to walk that direction, and you see my character kind of took that sharp right turn. And that behavior will happen pretty much every time we cross over this trigger. And it's because of the way our cameras are angled and the fact that we're actually doing player movement based on camera rotation. So it's partly the reason why actually old video games did tank controls in the first place, was kind of to solve this problem basically with the fixed cameras. But whenever you cross over, you're always going to have that issue, and it'll be different depending on how the cameras are angled. And you may have a perfect angle of your two cameras where you don't get the issue, but most cameras are going to have some type of issue. And this one was actually even worse than our last example. If you saw, when I go through, I'm basically going straight towards that green arrow, and as soon as I cross, the character wants to go the other way. And there's a fix for that, and we're going to do it in this video. First, I think we're going to open up our camera manager. So go to your content drawer, and let's find our camera manager. Double click that open, and you'll see our set active camera function that we created in the last video. We're going to change something really small here. So right now, all it does is it sets the current camera, whatever camera is updated when you go over the trigger, to be the current active camera. And we also enable our tick on that camera. We want to also keep track of what the previous camera was, and that's going to be really useful later on when we do the code for the next part. So to do that, we need a new variable. So if you click on your current active camera variable down here, we'll just make a duplicate of this, and we'll just name this previous camera. And I cannot spell today. Let me get rid of that. Previous camera. So that should be good. And we want to set that before we set the current active camera, because once you set the current active camera, that variable changes to be whatever this new active camera is. So we want to do set previous camera, and we want to do that before we actually set the active camera. And then this will actually just be whatever the active camera was. So if we drag that variable here, we can hook that up like that. And we'll just rearrange our nodes a little bit to be cleaner. So now, because we're setting this variable before we actually set this when this function's called, the current active camera is actually the previous camera, and then it just stores that in a variable, which we will use later. Now we're going to use something called an event dispatcher. And the reason you want to use them, they're basically like signals that broadcast from one blueprint to another when something changes. And in this instance, we want to know when our current active camera changes, what that active camera is, and what the previous camera was. So to do that, it's kind of like creating a function. It's in this tab over here where you see event dispatchers. Just click this plus button, and let's name ours OnCameraChanged. And event dispatchers are kind of like functions. They can have inputs, so do compile. And then with that selected, if you go to the details panel, you'll see this little plus under inputs. Click that for a new parameter. And then here, similar to what we did just in this function itself, we're going to have a couple inputs for cameras. So search master camera under type, object reference, and we'll name the first one old camera. And then click the plus again. Let's create another. And then name this one new camera. Cool, and that's all we need. So let's drag our event dispatcher into the graph and then do call. We're gonna do it right after we set the tick enabled for that actor. We'll just hook that up there. And then under old and new camera is going to be our current active camera. And old camera will be our previous camera. Just like that. And just double checking that our blueprint looks good. So yeah, that's the only change we need for Camera Manager. So compile and save. Then let's navigate back to our third-person character. Let's see our begin play, so we're going to bring that into the graph. So right-click in an empty space in the graph and search begin play. Perfect. So first thing we want to do, we want to get a reference to our camera manager like we did in our other blueprints. So search get actor of class. And let's find camera manager. And this is our custom camera manager, not the default Unreal one, just to mention. And then promote that to a variable. We'll call it camera manager. That looks good. Then what we're going to do is we're going to bind to that function, to the event dispatcher that we just created. So drag off of camera manager and search bind event to OnCameraChanged. Just like that. And this is really how you utilize those event dispatchers. So basically when the camera changes, this event will get triggered. And we have to create a custom event here so that we can actually do some logic off of this. So add custom event. We can just name this OnCameraChanged character, just to distinguish it between these two. So whenever that happens, this will fire, and because we did those inputs, we have access whenever that happens to our old camera and our new camera. So what we want to do right off the bat, we want to get our old camera and just check if it's valid. And let's actually do the other one, is valid, like so. Then we want a variable to basically say, is our direction lock active? So the way we kind of want this input to work is whenever we cross through a event trigger, or sorry, a camera trigger, we want to maintain that current direction until the player either moves their stick or their WASD keys beyond a certain threshold. So whenever it goes through, we want to initially lock that input when the camera changes. So we need a variable to do that. So let's go into the variables, click plus, and let's add one called direction lock active. By default, it can be false. Drag that into the graph and do set direction lock active. And when this is not valid, we're gonna set that to false. So that'll be the first thing we do. Then when it is true, when this old camera is valid, we want to do a branch. There's gonna be some logic we're gonna do later on, which without our current input, it's probably gonna be harder to set a lot of this up. So I think we may just do this for now and come back to this, which yeah, I think we will, because there's actually a lot we have to do here, but we need some kind of prerequisite stuff done under the move function. So this will be good for now. At least we are binding to our function, binding to our event dispatcher, and then we have our initial setup here, which is fine, and we'll continue off this later. So let's actually open up the move function, and we'll continue there first. So this is going to change quite a bit. Let's just get rid of our control rotations. We don't need these for now. And let's kind of reorganize this slightly, because this could get a little messier later. So let's drag that way, drag these over here. But the very first thing I think we want is right off of our move, we're going to want to get the current input. So we're going to save this as a 2D vector. Because our move input is an X and Y axis, it's only two floats, which we want to then make into a 2D vector. So to do that, do a variable, and let's call the new variable current input 2D, and then search 2D vector, or vector 2D rather. And then it's this one down here. Just make sure you select the right one. And then let's do set current input. And if you hover over this pin here, you can do right click and do split struct. And then you'll see we now have our 2 axes, and just feed in X and Y directly to those. Then off of that, let's get vector length. Vector length 2D. And then we're going to promote that to a variable. And we're going to do a local variable, because actually we won't ever need this outside of this function. So we'll do a local variable, and we'll name this one input magnitude. Like so. Hook that up there. Or actually hook this up first and then that. Yep, that should be good. And then to clean things up so that we don't have to drag off of here into this and then also into here, we're just gonna hook up, we're just gonna get that variable. So drag out your current input 2D, split the struct, and then do your, let's just make sure we're doing the right one, X into the scale value here, and then just get rid of this node. And then do the same over here, but with Y. Sorry, I didn't copy it. Yep, just like that. Okay, that should be everything we had before, and then just hook it up here. Okay, that should be good. So now we're just storing our current input and also the magnitude of our input, which will be important in a second. So let's give ourselves some more space because there's going to be a lot to do here. So drag that out. Next, what we're going to do is we're going to get that variable we created, our direction lock active. And then we want to branch off of this. So when it's active or not active. And then the first check we're going to do off of true is we're going to check if the input magnitude is less than the input release threshold. And that's kind of that threshold I was talking about of like how far you want the player's stick to move or the WASD keys to move before you actually break that input. So we're going to create a variable for that. So if you go under variables, click plus, and we just need one called input release threshold. And it's not going to be a vector 2D, this is just going to be a float. And then we want to set that default value to something like maybe 0.1 to start. And these will all be tweakable, and something you'll notice once we get this all set up is you're probably going to have to like finesse these numbers. Otherwise you might have like a scenario where the character input locks like too firmly and you have to go too far moving the sticks to actually get the input to change to the new camera. So if that happens, you'll want to tweak these numbers and refine them however feels nice to you. It'll be kind of up to you really. You'll have to play it and see what feels good. But we'll start with 0.1, that should be fine for now. And drag that into the graph. And we have our input release threshold, and then we need our input magnitude, which is our local variable, so drag that in as well. And let's just do a less than node. And then off of that, we want another branch. So this is the true path. On the true path, we're going to check this. On the false path, we're just going to feed directly back into our existing input logic. So when this is false, just bypass everything and go straight back to here. And then we're going to do that a few times, but just to keep this organized, let's just add a reroute node maybe. Something like that for now. And we'll probably have to continuously shift this around because there's going to be a lot of logic here. So that looks good. Then off of the false, or actually off the true path for here, we're actually going to do the same thing we did earlier, where we're going to set this to be false. And sorry, that's actually off the true path. So if input magnitude is less than input threshold, disable direction lock active, and then feed this back into our existing logic. So something like that. That should be good. So off the false, we're going to do another check. So drag off and get a branch. And for this check, we're going to use our current input 2D, normalize that. And then we're going to use dot product again, which if you remember from the first video, we did. So we're going to get dot product, of that and of the initial input direction, which we don't have a variable for yet, so let's actually create that. So drag off that and do promote to variable. And let's rename that initial input direction, like so. And then off that dot, we're gonna do less than. And we're gonna check against a stick angle tolerance. So we don't have a variable for that either, so let's create that. Under variables, do plus, and let's make one called stick angle tolerance in degrees. So get that value, and also we can make that default something like 35. So when you move beyond that like 35-degree angle with the stick or with your WASD key, that'll actually trigger us to break out of this direction lock. So we'll do 35, and then let's get cos radians and hook that up to the less than. So that should be good. And I think that's everything we need there. So that's our second check. Then off the true path, let's set our direction lock active also to false. And then hook that up to this pin that we created here, just so all of the kind of times where we're setting this direction lock to be false, we're just going back to our default input. Because the only time you actually want to maintain that input lock is when that's true. So if we do that, we should be good. And then the last thing I think we want to do here is, if that is true, so, or if, if the stick angle tolerance is still less than that, and if the input magnitude is less than the input threshold, that's the only time where we actually want to do something other than what we're currently doing. So we want to set our movement input, and then we want this to be the locked world direction and our input magnitude. So scale value is going to be input magnitude, and then this is going to be our locked world direction, which we also don't have a variable for yet. So let's promote that to a variable and just call this locked world direction. Okay, so that should be good. And I think that's everything we need in this blueprint for now. At least everything in the move function. So now let's go back to our event graph, back to our begin play logic, and now we can kind of move past what we set up here initially. So right now, just to double check, we're getting our camera manager, we're binding to the event, and then when old camera's not valid, we're setting that to false. So that's all right. Now we can do our check here. So what we need is our current input 2D, which we got earlier, and then similar to what we did before, we're going to get vector 2D length, sorry, and then we're going to check if this is greater than or equal to our input lock threshold, which is a variable we don't have yet, so let's also create that. So drag off promote to variable and call it input lock threshold. Perfect. And then let's give that a value of like 0.2 for now. And again, these are all the values you're going to have to tweak based on feel, whatever feels the best when you're playing. So that should be good. That's the check we want to do there. When that is false, we also want to set direction lock to be false. When it's true, we're going to set our locked world direction, which we just created our variable for. So do set locked world direction. And then we're going to have to do a little bit of logic to figure that out. So to get that, we're actually going to want our old camera. And then something super important here, we don't want to get our forward vector and right vector from this old camera. We actually want it from the camera itself, the component. And the reason we want that is the actor doesn't move, our master camera actor. that stays in place, but we have our individual components, and the camera, if I remember correctly, and we can actually double check this. Master camera. Yeah, the camera is parented to our rail pivot spring arm. We're probably just going to use the camera component itself. I think that'll be the most accurate. So off of this, drag off of old camera, search for camera. You might have to scroll down quite a bit, but it'll be, usually the components are all kind of right at the bottom when you search this. So where it says get camera, that's what we want. And this is that camera component in our master camera. Then from that, we want to get its forward vector and its right vector. And then we're going to use both of those. So what we can also do here, let's actually just move some of this down just to give us a little more room. So what we can do there is we can split these vectors. So right click on the little output node there, do split struct pin. And then now we have all three floats from our vector for the camera's forward vector and right vector. We only actually really want the X and Y. So what we're going to do is drag off of one of those and do make vector 2D. And then plug in the Y there. And you can just copy that node down here and do the same. So we don't really care about the Z, we just want the X and Y for both of these. And then for both, let's normalize them. And if you hover over, this just creates a single unit normal version of the 2D vector. So we want that for both of these to be safe. So let's grab that like that. Then what we want to do is we want to multiply the normalized version of these 2D vectors with our current input 2D. So let's do multiply and then drag in our current input 2D. And we actually don't want to multiply by the whole current input 2D. We want to do what we did for our previous movement. So you know what, let me double check that too, just to make sure we're going to use the right values. We were doing right vector X, forward vector Y. So yeah, we want to do the same thing here. So let's split that and do Y, just the Y multiplying. And then on the right vector, we want to do just the X. And I think that should be right. Yeah, I think just like that. Then what we want to do is add those together. Normalize again. And then we can break this 2D. We have our X and Y. And then again, we don't really care about Z, so just feed X into the world direction and Y into the world direction, just like that. Okay, so now we want to set our initial input direction, which we haven't done yet. So you remember we created this variable, but we still haven't actually set this. So drag it out into the graph and do set. And then to set that, it's just going to be the current input 2D normalized. And then hook that up to initial input direction. So that should be good. And then the very final step is going to be setting our direction lock to actually be active, which if you noticed, pretty much we've only been setting it to be false. There's nowhere in any of our chains yet that's actually setting that to be true. And this is the spot where you want to do it. So drag that out into the graph, do set direction active, and make that true. So now I think that is all the logic we need. We have set some default values on some of these thresholds, which again, you can tweak, but we'll just test to make sure everything's working. Let me just double check again. Yeah, I think that should be good. So let's click play and see what happens. Okay, so if you remember our test from before, when I crossed through this trigger, what we were experiencing was the character wanted to turn right, even if I was trying to go in the direction of the green arrow. So with everything we've done now, we should be able to lock the character's movement into the direction that they were kind of desiring to go for a period of time until they move their stick beyond that threshold that we set. So we'll give this a shot. I'm going to walk again straight towards the green arrow, And I'm going to keep my stick in that direction, and we'll see what happens. Yep, now it works. So now there's no kind of flipping. The character is just going where I want him to go. And then as soon as I move my stick beyond that threshold, they can walk like normal, and they can go wherever I want to go now. So this feels way more natural. We'll test it with this one because this was a pretty drastic example where the character was going 180 when they would walk through. So let's try this again. I'm going to go towards the green arrow. Yep, now it's working. And then I move my stick beyond the threshold and they break out of it. And this feels way more natural. It's a much more modern control system, but still allowing us to get that classic fixed camera feel. And if you played the Resident Evil 0 remake, or the Resident Evil 0 or Resident Evil 1 remake, they do a very similar setup there. And it just makes sense. It's more intuitive for the movement. And that said, we're still going to do classic tank controls. That'll be the next video. And then I'll have a setup where we can actually switch between the two, so you can do both. But you can keep testing this, going back and forth. And if this threshold feels too sticky, like you're coming through and it takes a lot of stick movement to kind of break you out of that, definitely tweak those settings that we adjusted. And you can tweak that threshold to however you desire, and you can make it feel however you want. I feel like this feels pretty good, but if you guys want to tweak it and you find good values or better values, let me know in the comments down below. So that's going to do it for this video. Did you enjoy the tutorial? If you did, leave a like and subscribe. It'll really help my channel grow. Do you have any suggestions for future tutorials? Drop them in the comments down below. And if you need help troubleshooting, just ping me on Discord or on YouTube. I'd be happy to help. So thank you so much for watching, and I'll see you in the next one.